Okay, let's start with how do we actually get data into Grasshopper? For that, I downloaded the COVID-19 cases spreadsheet from our Wilton data of Europe of April 11th, 21, which looks like this. We have the dates split up, cases, death, the country and territory where it happened, the geo ID, which will be important, and the population data, which will help us to create some diagrams later. Then we also have another country ID and the continent. So how do I get this into Grasshopper now? I opened up Rhino Grasshopper in the background already. And the next thing I will do now is, as in every video, I will open the example file for you. And the first one is read Excel. So the first thing that we want to do is actually getting the file into there. And for that, we are taking the file path of our file. So this one here in Windows, and drop it here into a panel, and then give it into a file path component, which I do just for structural reasons. That is not necessary, but it often helps to structure your files. And then what we need next is the read Excel file component, which comes with the TT toolbox. It has this on here, Excel read Excel sheet, and you can you put the file path in second input and have three more inputs, which are run. So should the component read the file? Which worksheet should it take from the Excel file? As we know that Excel can have several sheets down here. And should it listen if the file updates? So we want to set the listen to false and the read to true, and the worksheet, as we only have one, can stay in one. And what we get out there is then the columns and the rows of the Excel file. If we want to look at it, we have the columns here, which shows us date rep, and then all of the dates which coincides here with column A. And then if we look at the rows, we have date rep, year, month. So everything that is shown in rows here in row number 1. So how do we now continue to work with these columns and rows? First, what actually goes with most Excel files is that we here in the first row, we have an indicator of what is represented in the column beneath. And so we first want to extract the first branch. And here we have to look at the factor that Excel doesn't start counting at 0 as Grasshopper does, but it starts as 1. So we want to have the first row of it and have to here actually put the number 1 into the branch component. The branch component can be found here under sets or and tree branch, or here at branch, tree branch. And tree branch has one setting to it, which says maintain path, which we actually don't want. So if we turn this on, it will give us the indices like it gets it here, which means the first row will be numbered by 1 and not by 0. We want to have it at 0 to have our data path clear. So 0 for the first thing is everywhere in Grasshopper. So we want to renumber and have here our list of what is actually the content of the columns. So the next thing we want to do is split the columns. Because as we have seen, in the columns, the very first item is always the title of the column, and we just want to get that out of there. So we split at index number 1 to only have the dates in there. Or for the next column, only the day of it. So we have every list split up to 1,260 items. And now we want to partition these because our list here still starts at 1, not at 0. So we can shift this whole list in this simple case just by repartitioning it. For that, we take the length of the list with the ng list length component and simplify and flatten this. We have 11 lists of 1,260, give that into the size of the partition and give a flattened list of all of our columns items into the list parameter, and then it gives out the same list basically shifted by one tree branch. As we now have partitioned lists according to these indices, we can now extract the branches of the data that we actually want to work with. So if we want to extract the countries now, those are lying in row number 6. So we are taking the branch component here with renumber again. These are at maintain right now because I haven't switched them off yet. And we want to set path number 6, and we get out one branch with the 1,260 country items of the whole chart. And the same we can do for the cases, which is index number 4, and with population data, which is index number 8. And for that, we have extracted 3 columns items to work with later on. Okay, so now that we have successfully imported data from an Excel file, we want to look at one more native format, which is the CSV that you can often also work with. And it is not as, let's say, structurally well built as the Excel file, as it does not have the columns, but it is only the columns separated with a semicolon. So the how to deal with that in Grasshopper is a little different. And for that, you should open the document of read CSV. It starts the same way. We import our file path and put into the read Excel file, which is here triggered by a toggle. And then we take the rows, which only has one item per list row. So if I show you that, it will take some while, depending on how long your list is. A side note to that, if your Excel file takes a really long time to be read by Grasshopper, convert it to a CSV file, as it will not take that long of a time. And the rows we get out of that are these. We have all of the rows, as I said, divided by semicolon. And now we can split these by the text split component, which needs the text of the rows and the separator, which will be the semicolon. And then you get out this, you get out the resulting text fragments of 12 items per row, which will basically give you your matrix. And at first, this will look like this. You have, this is basically your rows. These are your rows as you had it in the Excel file. So this would be, of course, in the other Excel file, but this is row number 1. Is here the first path, and to now have it as columns and rows again, we just have to flip the matrix once. We first have to simplify it to only have a single path number and can flip it, and then we have the same structure as we had it in the Excel file, and would have to split the list again after the index number 0 to only have the items. And what we do with the rows is that we take the tree branch path number 1, because it's Excel file list number 1, and we don't want to maintain, turn that off, have it at 0, and then we can then we have here all of the items of row number 1, which are the titles of our columns, and then we can work on with that. Okay, I'm back now at the Excel file, read Excel, not read CSV file, because our first example is going to have the Excel file in it. And now I am working a little further on this, and for that I am opening the basic work with data file, which does not really contain a lot more, but a few really important things to know about how to now deal with the data that you have extracted. And one really important set of 2 items that you will work a lot with is the create set and the member index. You can find this here under set and sets, member index and create set. And what create set does is that it looks at all of the lists, and it creates a smaller list of all of the items that are in it. So it gives you only a single time every value that is in it. And if we now take all of the countries, which are 1,260 values here, and create a set from that, we will get a set of 30 countries that are in it, which are listed according to their appearance. And since the Excel sheet was in alphabetical order, the list here is now 2. And the second output will give us the number of the index that all of the items that you gave in the new set will have. Mostly we will not need that, but only the set that is created. And what that is useful for is that you can now find indices of the countries. And now you can look for the indices, for example, in this list. So if I look at this list, we have all of our over 1,000 countries, which are only 30, and we want to know where exactly does, for example, Austria lie. So it has the indices 0, 1, 2, and so on. And Greece has the indices 471, 472, and so on. And we want to look for these numbers. And so we will do that with the member index, put the set to operate on, so all of the lists in here, and the member to look for from the created set. And what we get from that is a list of indices. And from this list now we see that each of our 30 countries, so path 0 to 29, has 42 items. And these 42 items are now the indices of the country. And what we can do with that now is that we can direct these values to the countries. So we would take the list, the branch of the cases, for example, which are for Austria in the first week or on the first day, 3,559. and put this list into an item selector, a list item component. And if we put this list in here and the item of the with the indices of that in there, what we get out is the list of the same structure as this, which is sorted by country, and then have it divided by the country. So we have all of the case numbers of Austria now in list number 0, and all of the items of Belgium, all of the case numbers of Belgium are in list number 1. And we could also do the same thing for the population data and look at that. And of course, it is always just one number of the whole population for all the time. And now we can continue to work with these numbers. So what we have here is the case number, and what we have here is the population data number. And since this is always the same, we can create a set from that again and then have 30 values, which are the population data of the country. And then we want to first look at what is actually the whole number of the cases. And for that, we used mass addition of all of the cases of the last weeks. So the last 42 days have the numbers and mass add them up, and we have 30 values then. So if we then mass add these up again, we have the whole number of infections of the last 42 days, which is 2.8 million or 28 million, not sure. And with that, we can just calculate a percentage. And if we look at that here, we see the numbers of how many infections of the whole European countries, of the 30 countries, were in one specific country. So we see here that 2.01% of all infections were in Austria. And to be able to deal a little more with data and pre-process our data for the coming up chart that we want to create, we want to look at the whole population of all countries, mass add that up, and have the number of 485 million, 453 million people in Europe, and then the percentage of people per whole population, how many of the population of one country does that represent of the population of Europe. And then we want to also check the percentage of the cases per population, which is in here maybe the most interesting. And it's 6%, for example, for Austria. So these are just some basic numbers that you can pull out of it. Of course, there are several opportunities more which make it more interesting. But for now, let's just continue with these numbers and see what graphs we can create from that.